Thank you for being here. I'm super hungry. I hope you are super hungry too. So I'll try to make this as painless as possible. This is going to be in English, but if you want to ask me questions in French at the end, I'm French, so we can just do that. So today is a live presentation of a blog that I wrote maybe 2 years ago on Medium. I don't know if any of you have read that blog, but it's all going to be about live demos, introducing you to Kafka, all the capabilities it has, viewing a little bit of code, but not too much, just understanding what's the role in your organization and how we can transition from a batch pipeline into a more real-time one. All right, so just about myself. So I'm Stéphane, and I'm an IT consultant and a Kafka online instructor on the Udemy platform. Did anyone take my courses here, by any chance? 1, 2, 3, yay, 4 people, excellent. If you haven't, you'll see them in a second. So I love Kafka, and I do production deployments, I write POCs, I wrote blogs, and I have 9 courses on Apache Kafka in total online. I'm on the Kafka Summit program committee, so organizing the Kafka Summit of London, New York, and San Francisco this year. If you want to connect with me, there is GitHub, LinkedIn, Medium, and Twitter, and Udemy. So that's just about me, and we can talk later. So Kafka comes from this very concept that you need real time. This is a cool quote that I like from Michael. He works for Confluent. And he says, if you need to cross the street, would you do it from the information you had 5 minutes ago? I don't know if anyone is suicidal here, but I'm not, and I wouldn't cross the street. I want to cross the street when I have real-time information. And in every business, you want to make decisions, or you want your customers to make decisions with the latest data. I guess that makes sense. So today, there's a challenge we want to solve. And it's when I get started on teaching on Udemy, it's a platform for online video courses. People were posting reviews about the course, but they were released and computed the average rating for a course every 24 hours. And that really frustrated me, because I'm a data engineer, and I wanted to have things in real time. So I decided to scrape the data from their website and make it real time. So all the source code is available on GitHub. And you can check out the link as well. So today I'm going to demo you this code and show you what's the thought process behind turning what is obviously a batch pipeline running once a day into a more real-time pipeline with less than 1 second latency. OK, who here is not familiar with Kafka? Everyone here is familiar with Kafka? Just a few people? All right. So quick reminder, Kafka is, end of the day, a pub sub. And you have a bunch of systems writing data into Kafka. And you have a bunch of systems taking data from Kafka, reading it, maybe in the meantime putting it back into Kafka. But in the idea, Kafka is in the middle and helps your data flows through all your systems. Data can be whatever you want. For some companies, it's going to be clickstream events. For some, it's going to be the pricing data, financial transactions, user interactions, and so on. And the systems that may need that data in real time could be databases, analytics systems, email systems, audits, name it, right? So that's just for what Kafka is at a very, very, very high level. Now, let's look at this batch pipeline. And first, I want to show you exactly what these reviews look like, so you get an idea. So this is the website from Udemy. And the course I'm going to scrape the data off is my Kafka for Beginners course, which is right here. OK, so here you get some information about the number of ratings, people that did post a rating, the average rating, number of students enrolled. And if you scroll all the way down, you get some distribution, and you get the list of all the ratings. And the idea is by scraping these data sources to click on see more reviews, and get that information. OK, so in terms of how I don't work for Udemy. I'm an instructor on it, but I reverse engineer the pipeline. And in my opinion, this is something that so in the middle, we have our database. And there is a REST endpoint somewhere, a web server. And it's taking a reviews for a course, and it adds this new reviews to an all new reviews table. And end of the day, when we do consult their web page, what we do is that we query this database for the recent statistics and the all-time statistics. So how do we get from this all new reviews to this table? There's probably a fraud detection job that every 24 hours looks at all the reviews that were posted, tries to filter out which one were fraud, like fake reviews, and which one were the real reviews, based on the different number of factors. Then it's going to append those to a table called fraudulent reviews, maybe another table called all the valid reviews. And then there's going to be a second job, probably a bad job as well. It's going to pull all the data from these valid reviews, compute the all-time average and the 90 days moving average, and insert that into this course statistics table. OK? This is something that's super easy to reason about. It's batch there's a bunch of frameworks to do this, like Spark or others. And so how do we transform this thing into that? How do we go from one to the other? Turns out it's actually not as difficult as you may think. It looks exactly the same as we had before, but now we have different blocks, and each block's of a different color. There's the green block, which is producing these reviews into Kafka. The dark blue block, I'm sorry, they look the same to you, but the dark blue block is this machine learning model Kafka Streams application to take these reviews and filter them. Then there is another Kafka Streams application, that's the bottom blue block, that is about computing these averages in real time. And finally, there's going to be this orange block, which is we get all this stream of data from Kafka, and we're finally going to insert it into a database to expose it to our end users. OK, so we're going to go over all these blocks one by one. So we'll see the Kafka Producer. We'll see the fraud detection Kafka Streams application. We'll see the review aggregators Kafka Streams application, and finally, the Kafka Connect Sink. Now, obviously, we don't have the time to look at the code for all of those, but I'll try to keep it as high level as possible and at least elevate you to the idea that these are possible. So, the reviews producer. When you start with Kafka, you need to get data into Kafka. That makes sense, right? And so in Kafka, something that produces data to it is called a producer. So here, we want to use the REST API of Udemy to get all the reviews for a certain course. Then we're going to produce these reviews into Kafka, and they're going to arrive into a Kafka topic called reviews. So the Kafka topic is similar to a concept of tables in databases. The idea is that it's a log, it's append only. And so every time we get a review, we send it to Kafka, and it gets appended to the log. So without further ado, let's get started with the live demo, and we can look at the API. So the good thing about live demos is that I always get something wrong, but let's see how we go today. So starting Kafka, there is this cool CLI called the Confluent CLI. And you just do Confluent start, and it's already running. Excellent. So I'll just destroy it. So the Confluent CLI basically allows you to start a bunch of Kafka components, such as Kafka, Zookeeper, Kafka Streams, all that stuff for you automatically. And so if you just do Confluent start, I'm waiting for this to be done. If you just do Confluent start, here we go, then it's going to start for you all these components. So when you have a Kafka cluster, you first need to have Zookeeper. Then Kafka can get started after Zookeeper. And then there's a bunch of components, such as the schema registry, I'll get into that later, that are created. So I'm waiting for those to spin up. But while we're at it, let's create a few topics. So the first thing we have to create is the Udemy review topic. And we can do this using the CLI. But today, I'm actually going to not do that. I'm going to do that using this app called Conductor, which is something that we developed at DataCumulus. And so it's just a GUI for Kafka. Think as in a graphical user interface to deal with your Kafka cluster. So you can go in your topics, and you can create a topic. So up, action, create topic. And then you just need to enter the topic name, which is going to be Udemy reviews. So where is it? Udemy reviews. And you would specify the number of partitions you want, and so on. So up, 3 partitions, create, and we're done. So I'm not going to do this manually for all that. I'm just going to use the CLI now, but we'll get started with it. OK, so now we have all the topics being created for all this purpose of this demo. And now let's push some data. So this is a project, and here's all the components I'm going to show you. But the first one is this reviews producer project, and I've already built it. So what we're going to do is just consume that topic, Udemy reviews. So I'm going to a consumer is the topic Udemy reviews, and it's going to be Avro format for the value, and I think it's a string for the key. We're going to start this consumer, and now it's started, and here we're going to start a producer. So for this, I'm just going to go to my terminal. Oops. OK, why not? Exit presentation mode, where are you? OK, so we're going to launch a terminal. And in this terminal, we're going to run our producer. So here we run our producer, and it's going to fetch data from the Udemy website. This is all the reviews it's fetching. And hopefully, in here, we should start seeing, yes, all our reviews flowing as a consumer. So we see all our reviews coming in, and it looks great. So how does a producer work in the backend, like maybe you want to see some code. So let me go in there. So there is a main loop. And the main loop is very simple. And I'm going to zoom in. It's just starting a REST client and starting a review producer. And it's going to fetch reviews with one thread and send them with the other. And if we look at the producer thread itself, when you start a Kafka producer, you have two things going in. You need to first create a bunch of properties. This is how you configure your producer to talk to Kafka. So here it's configured to have a certain mode of acknowledgement, infinite retries, idempotence, and so on, just a bunch of configs that you can set. And finally, in here, we create a Kafka producer, and we do send, and we create a producer record, which is our message, which contains an Avro document of our reviews. So pretty high level, but we create messages that get serialized in 2 bytes and sent to Kafka. And therefore, we can start having consumers to get these messages in real time in the UI or in the console. So that's the first step. Yay. We're getting data from the web. This is real data flowing in. So we have our first step, which is our review producer. Now our reviews are in Kafka. And I mentioned briefly Avro, but now I want to talk to you about what it is. Who's familiar with Avro here as a data format? OK, maybe half the room. Excellent. So you all know CSV. You probably all know JSON as well. They're text format. And they don't have strong schemas. Schemas are always inferred for CSV and JSON. Avro is taking it to the next level and saying, OK, can we have something that looks like JSON, but also has a schema attached to it? And that schema is going to be strongly enforceable. And on top of it, we'll have the capability to move our data, to evolve it in a backwards or forward compatible way. So that's the idea behind Avro. So Avro is a schema and the data together. And so that makes the message a lot bigger. But if you somehow externalize that schema and send it to a schema registry, then the bytes of the actual message are really, really, really small. Imagine JSON, but instead of the name of the field being super big, it's just one like very, very small, 4 bytes or whatever. Then you can have really, really small payloads. So this is the idea behind what's happening. Our producer is actually sending the schema and registering it to a schema registry, and that's an external component of Kafka. And it's sending the Avro payload, the content itself, which is really small again, into Kafka. Now, as a consumer, to read that data, it's going to receive the Avro content from Kafka, but it's going to need the schema to deserialize it. And so it's going to ask the schema registry, hey, what is the schema for this message, and put together that message back. This is quite efficient because your schema doesn't change over time. It remains very stable. So you only need once to register the schema, and you only need to read that schema once as well from the consumer side. So there's no overhead. And this is actually a much more efficient pipeline. So that was in 2 minutes, the schema registry. All right, so now we have the data flowing in Kafka, and we want to process it in real time. For this, we're going to use Kafka Streams. Now, Kai just before talked to you about Kafka Streams a little bit in KSQL. So I'm just going to do a fair introduction as well to this. But the idea is that we have our data sources. They've been produced into Kafka, and we want to process them in real time. That means reading them, computing something on top of it. But we want to make every other application get that new stream of data. Hence, we want to put the data back into Kafka. So to do that reading and writing, you could write your own consumer followed with a producer, but that's really painful to do. Instead, there's this Kafka Streams library, which builds an abstraction on top of that concept and is meant for Kafka to Kafka transformations. OK? So it's a library. It's written in Java, and there's a Scala API as well. So why am I talking to you about Kafka Streams? Well, we have a reviews topic. It's in Kafka. And we want to run a fraud detection job. Which reviews are legit and which reviews are not legit? Maybe that fraud detection job is backed up by a machine learning model to qualify a review based on its attributes. The age of the user, how many courses done, how many times has been subscribed on the platform, how many reviews is posted in the last 24 hours, that kind of metrics. And out of it, we send the data to 2 other topics, the fraud reviews topic and the valid reviews topic. Make sense? Following? All right. So let's look at the code for this and see how we can make this work. So back in IntelliJ, and the reviews producer is still running. That's great. So I have this Udemy reviews code, and let me show you what a Kafka Streams application looks like. So a Kafka Streams application looks exactly like a producer, as in the beginning, you need to provide some properties to your Kafka Streams application, namely, where are your Kafka brokers, where do you want to start reading from, and how do you serialize and deserialize the data. And on top of it, there's this cool mode called exactly once processing, which guarantees that you won't read or write the data twice, which is quite a nice guarantee to have if you do financial transactions processing. And when we're done, we create what's called a topology. And a topology is a high-level abstraction of how your data should flow and be processed and where the output is going to be at the end. So this is code. Even if you're not an expert in code, everyone can read this. So here, you build a stream from an input topic, from a source topic. Then you're going to branch out that topic based on whether or not if it's a valid review or not. And with these two branches, you're going to sync them into new topics, which is right here. This two right here says you're going to put them into another Kafka topic. Now, for the isValidReview function, this is my most advanced machine learning function. It's an if statement, and it takes 5% of the reviews as fraud, and that's it. Yeah, a few data scientists in the room. We all wrote this once in the day. So 5% of the reviews are going to be fraud. So let's just run this. So I'm going to start another consumer. And this time is going to be the valid topic. And I'm going to start another consumer if I have space. And this time is going to be the frauds topic. Actually, this is JSON, Avro, and this one as well should be Avro. And let's see how we go with this one. So let me start our Kafka Streams application, which is right here, and see how we go. So now it's starting, and it's doing all its things, and here we go. So it's very quick, and you can't really see much, but it says valid fraud, valid fraud. And if we go back to conductor, we should be seeing the reviews flowing in and out. So perfect. So we have our reviews. They've been consumed here. That's the fraud, and so on. Sounds good? So far, so good? All right. And the reason there's no data flowing anymore is because my main producer just stopped. So obviously, data won't be flowing in. But that was very quick. That was like super quick to compute the frauds. OK, next. We're doing good so far, right? Very simple. Now a little bit more complicated. We have this stream of valid reviews. How do we compute an aggregate? One that's going to be long-term and one that's going to be more recent. So you can always use Kafka Streams for this as well. And it's not just like a simple library. If your fraud go this and go there, there's aggregation capability. There's windowing capability, all in real time, all resilient, distributed, name it, and scalable. OK, so the idea is we're going to run our aggregations from the Kafka Streams library. And we're going to compute two types of aggregations, one all-time aggregation statistics and one windowed statistics, where we understand what's our average of ratings for the last 90 days. So that's the concept of a windowing. Maybe you have other wants of windowing for your company. Maybe how many times was this credit card used in the past hour? And if it's used way too many times, probably something's going on, or someone is having a crazy time shopping. In any case, block the card. So let's see how we can go. So this is our Udemy Reviews Aggregator Kafka Streams application. And let me show you the main aggregator function. Excellent. So again, our properties, but I'm not going to repeat this. And our Serde, we also don't want that to look at it. But here's the more important one. So we look at our reviews, and we read them. But this time, we're going to infer the timestamp of these reviews from the actual timestamp from the data. You can have another type of timestamp in Kafka, which is the time the data was received in Kafka. But here, that makes no sense, because I just did a one-time load into Kafka. And here, we're going to compute our long-term stats. For this, how do we do it? Well, we take our reviews, and we group them by keys. So we group them together if they belong to the same course. Here, our message key is the course ID. And we have an aggregator, which is what is our empty state? What do you start from? Well, no ratings, no average. And what happens if you add a review? What does your average become, and what does your rating become? And so there's this review aggregator function I'm not going to tell you how to write an average. I hope everyone can do that in this room. But you get the idea. OK, so we have this review aggregator. And what we do is that, OK, we have a table out of it, like a streaming table out of it. In the end of the day, we want to output this into a Kafka topic. So we'll do our long-term core stats to a stream to an output topic. And for the 90 days average, it's a little bit more complicated. We have to define a time window. And the time window can be defined in so many different ways in Kafka. There is hopping window, overlapping windows. There is session windows, other ones. And so for this, in this case, we say, OK, it's a 91 days window. And there's a 1-day hopping. And just create a window of that size and advance it. So we create then a filter. So we filter for if the review expired first, because we don't want to compute an average on all the reviews. Then we group by key. We window by that time window, meaning we're going to have different windowing averages. Then we aggregate it using the same review aggregator. And finally, we output this into Kafka. So a little bit more work, because now we have windowing going on. But all this code can be read pretty naturally. It's all English. And yeah, we should get our recent stats. So the cool thing about this application, if you see, is that your Kafka Streams topology doesn't have to be A to B, and that's it. Here, I have different branches, different top sort of computations, and they all happen as part of one application. So you can go pretty crazy with your topology. You can do some very interesting transformation, very interesting topology. And why don't we run this? All right. So I'm going to start yet another consumer. So our recent stats consumer. So let me just, oops, not this one. So let me stop these. So we're going to start a recent stats. And it's going to be Avro. Hopefully that works. And then we can start another consumer. And that's going to be for our long-term stats. And again, Avro. OK, so we have our 2 consumers somewhere around here. I'll just put them here so we can see those. And so what I'm going to do is run this Kafka Streams application. So it's another Kafka Streams application in another JVM. And if everything works very quickly, when it gets started, in Conductor, we should start seeing some data. Fingers crossed. And nothing much is happening. Why not? This is the perks of doing live demos. With me, it always messes up somewhere. Even though it works last night, you never know. OK, no, here we go. Now it's starting. OK, so it's finally computing some stuff, probably because there was a lot of data to backtrack on. But here we get our, this is long-term stats. I can't remember. One is long-term, one is recent. And if you look at the average rating, if you get really hawk eyes, this is 4.65 and 4.60. So that means that, yes, the average is different for long-term and Windows, which is a good thing. So now we have this entire pipeline, computing averages in real time, putting this back into Kafka. But as an end user, we still haven't exposed that to a website, right? Which is what we want to do. So let's move on to the next part. This next part is Kafka Connect. So in the same picture that I showed you before, our Kafka Streams application was modifying the data, putting it back into Kafka. But now we want to expose it, have it in a database, something that a Django application or whatever can reason with. So we're going to use the Kafka Connect framework for this. Kafka Connect is a framework. It's built around connectors. And these connectors are pre-written pieces of code that allow you to quickly take data from Kafka, put it in Postgres, Elasticsearch, S3, HDFS, whatever you want. But also there's Kafka Connect sources, which allow you to take data from these sources, your databases and so on, and put it in Kafka. This is the idea that if you want to put your data from Kafka to somewhere else, someone probably has written the code for you somewhere, and you just want to leverage that. So that's the Kafka Connect framework, and I'll show you how easy it is to use. So here, what do we want to do? We want to take our recent stats topic and our long-term stats topic, use Kafka Connect JDBC sync, JDBC to send that to a database, a Postgres database, and it's going to do an upsert into our Postgres table. Then you can build your application normally and just expose that data. So let's look at how this works. For this, I'm going to start Postgres, which I don't think I have done, so I'll use Docker Compose for that. and it's going to start a Postgres database for me. Excellent. And so that Postgres database has nothing. I just started it. And now we're going to load our Kafka connector. So let's look at our connector and see what the configuration looks like. So here, I did not write any of that code for how do you take data from Kafka and put it in Postgres. I just wrote this configuration, and that's it. So that's the power of Kafka Connect. I don't have to think about that Java code to take data from Kafka into Postgres. Probably a lot of things I wouldn't think about. So here, I set up my connection URL, my user, my password, the type of mode I want to insert into, so it's an upsert, what are my primary keys, whether or not I want to auto-create these tables, what topics, second to last line, what topics I want to write into Postgres, and off we go. So let's have a look. I'm going to connect to my database, and here I am. I'm in with my database. And so as we can see, there's no tables in here. I can't even remember where they were being created, but let's check it out. So I'm going to load that connector. Boom, done. The connector is loaded. So if I go back here and look at my tables, and I'm going to disconnect and reconnect. This is probably going to be a better way to get my new tables. So here in public, I get my long-term stats and my table. You can't see much, but there's a long-term stats table, and I can select the rows. And there's a recent stats table, and you can get the rows as well. But how cool, right? Data is in Postgres, like real time. But we can do so much more, right? We can now run this entire pipeline, which is running. We can run it with other courses. So now what I can take is take more courses and run the same producer. And as we do this, our reviews are going to be sent and created and so on. And all our JVM processes are going to run, our fraud detector, our aggregations, and so on. And all of that, if I refresh this, is going to end up in Postgres in real time. And the data is going to change as I refresh it. This is the long-term stats. If the short-term stats, well, it's not yet short-term because it's starting with the history. But all that data is going to end up in Postgres in real time. And now you can see really the power of this thing. We just run a couple of JVM processes, and we have data flowing into that one system. So that's a short introduction to Kafka. But hopefully that's one that you can make sense of and like. You did see a lot of, hey, what's our pipeline looking like? So we went from this to this. And in about, well, that took me more than 30 minutes to write, obviously. But in about 30 minutes, I did walk you through an entire transformation of a batch pipeline into a real-time one. So, mission completed. Thank you so much. And if you have any questions, let me know. Otherwise, let's get to eating.